Good morning all. Well, I didn't pack this away. In fact, I can't put it down. I just keep adding more and more bits to it. One thing I have added is a second square wave oscillator there. So you've got one square wave oscillator at the top, another one at the bottom. Now those are in the original project design. So here's the one square wave oscillator, here's the other one. They're triangle wave oscillators at this point, and then there's a comparator which squares it off, and you've got a pulse width control to get nice phasing sounds. And at the same time as building this breadboard version, I'm making up these printed circuit board versions for my first sort of semi-project, which is the spectrum analyzer, where I've just got a load of filters and bar graph displays. I will speak into it and lots of bar graphs will bounce up and down. So let's connect it up. Now what I'm going to do today is modify these filters, the filter frequencies. So you can see here with the components, which are all ready. At the moment, I think I've got 4, 5, 6, and 7. So they're all very closely spaced. I'm going to go for 3, 6, 9, and 12. Now they're actually 1 octave apart because the original design had these filters a third of an octave apart, and I'm going to do every 3. So I'm picking these central frequency bands an octave apart. I'm hoping that will make this a little more intelligible. So let's connect up my active speaker on the output. This is a little mixer stage on the output. Switch on the active speaker. Right, I'm going to have to put the power supply on. Right, 2 grounds to link the 2 battery packs because we've got positive and negative about 10 volts. This goes to negative. Now the other day I connected this up in reverse because I was a bit cavalier about my wire colours. So I actually put the positive and negative 12 volts the wrong way around. These wires got quite warm, but amazingly all the components survived, which is probably a good thing because that would have taken a heck of a long time to troubleshoot. Let's put 12 volts there. The speaker goes thump. Plus 12 volts there. Oh, and we can hear a tone. I'll turn that up. Now it's hard from an overhead shot to get a real sense of the complexity of this circuit, so I'll do a little bit of flying around. That LED has got a 10k resistor because it's sitting across the 20 volts, so I thought I'd need quite a high value resistors. So we got filters here, rectifiers, smoothing, and some other gubbins, can't quite remember. These are the 2 oscillators, as I say. I'll just play with those a little bit. They're both at the same frequency, so let's raise one of them to a 5th, I think that is, and an octave, and then you can play with the comparator inputs, and that gives you a nice phasing effect. Let's do this one. So 2 oscillators there, more filters here, so I'm going to have to change all the capacitors in these filters, and these are my voltage controlled amplifiers at the back here, which then go into this final mixer stage. So let's just do a little fly past there so that you can see all the components. It's just fab, isn't it? Right, let's just disconnect that tone. I'm just feeding the output of the tone generators straight into the mixer amp there. I can disconnect that by pulling that wire out. And now let's start a YouTube video where some chap is yakking on about something. I can't really say who it is because then there may be copyright issues, but see if you can work it out. Let's start him talking. And now various people ask me to adjust this, and let's adjust the tone generators while he's speaking. Let's bring the other one down. I'll take those quite low. Now, as you can hear, it's still completely unintelligible. You can't really understand what he's saying. But I'm hoping that if I switch to these frequencies, which are an octave apart, we'll have a wider spread of frequencies and there'll be more sort of top end in here. And we might be able to understand what he's saying. So I better get started on that. Now this top channel here is probably channel 4. It's got 33N capacitors in at the moment. I'm going to change those to 39. So that one's going to go down in frequency. Here are my 39Ns. So I'm just going to pull these 4 caps there and the 4 caps on the corresponding analysis filter. Put the 39Ns in. Do the same with the other filters. Now it's going to take quite a while. So although I'll probably film this in real time, I'll speed it up in the edit. Right, before I start, I'm just going to pull out my sort of signal tracing wire, which I use to feed the oscillator directly into the mixer, or indeed the speech input. I'm also going to pull out these 4 wires which link the output of the analysis section, which measures the level of sound in these 4 channels and then switches on the VCAs or fades them up as the energy here increases. Let's take those 4 wires out. I'll put those all back in later. Right, let's start pulling the components. Now I'm supposed to change not just the capacitors. I've got to try and remember where these go. Perhaps for the moment, until I learn the process, I'll pull them one at a time and replace them with these. There are other components that need changing. Some of the resistor values need changing, but I may not bother with that initially. So that went across there. So, how are you today? What are you doing today? Are you building a vocoder? Probably not. Right, that's the first pair done. That didn't take very long, so this shouldn't take very long overall. Right, so 27 ends are coming out. That's 1 to input node and 2 to input node. Right, I think that's it. I think that is it. Shall we fire up the speech and see if we can hear anything? Let's try it. What did I do? Did I switch it off? Oh no, I took these out, didn't I? The controlling wires. Let's put the controlling wires back in one at a time. We'll start with the low frequency. So that's now 400 Hertz. That's there. And 800 Hertz goes here. Didn't quite sound like an octave, did it? But 1.6 kilohertz is this one. And this one is 3.2 kilohertz. Well, it's not a lot better. No, it's not really that much better at all, is it? Let's raise up the frequency of these 2 oscillators. Right up to the top frequency. So the higher frequencies are giving a little more of a sense of sibilance, like s and t and ch sounds. But no, that's still not very intelligible, is it? Now, it has to be said that where in the actual circuit there are full-size potentiometers for adjusting things like frequency and phase and whatnot, I've got presets, and where in the circuit they have preset pots, I've actually put in half-value fixed resistors. So the preset pots here, which are supposed to be on the inputs of these filters, which are 1K, I've just put in 510 ohm fixed value resistors. So I can't actually align this thing. I can't set it up as per the setup procedure, and there is a setup procedure. So there's probably a lot of distortion in here. But no, I was hoping that would be a fair bit clearer with these higher frequency bands than with the 4 bands all quite close to each other. Let's try a bit more tone adjustment. Bit of phasing. Now, the other thing that affects intelligibility in the final design is that signals from the top 2 filters, 13 and 14, which are the highest frequencies, are used to detect sibilance like s, t, ch, and that. And they trigger a comparator which feeds white noise through into the output. So every time someone says s, then a sh or a s sound will be fed into the output. I think the way this circuit works is that it actually replaces the synthesized sound. So briefly it will flip over to noise and then flip back. So that massively helps when you say something like she sells seashells on the seashore or something like that, where there's lots of sibilance, and that will actually come through on the output. So no, it seems that you can't build part of a vocoder and expect it to sound like the finished vocoder. I mean, it sounds like a robot voice, but it's not that beautifully smooth vocoder sound. Yeah, and there are lots of things I've missed off here. I mean, I haven't bothered with the slew rate control inputs. I've actually just linked across drain and source on this JFET here. I haven't bothered to build this bias network to pull this point slightly up towards 12 volts. You have to build this potential divider and then link that to all the bias inputs on all the channels. Haven't bothered. Haven't bothered to put this sort of pull up and down control here to adjust the gating point of this. Just left that off completely. I put a fixed 11K resistor in there. Haven't bothered with this pot. I just linked straight across. So there are lots of things which I've shortcuts that I've made, and so it's not surprising it sounds a bit grim. Now, if you're wondering why I'm building both a breadboard version of this and also building it up on these proto boards, well, the breadboard version really is so that I can establish a sort of positioning for the components, and then I copy it directly onto these breadboards. These breadboards are pretty much laid out in the same way as these proto boards are laid out in the same way as the breadboard. There is an additional rail on the outside edge there, because this has 2 rails. These breadboards only have 1. So I've made this outer rail ground. This other outer rail is also ground. I've also made these 2 inner rails ground, and of course they don't exist on the breadboards here because there's just a sort of slot, a gap there. So in fact, you can get this more compact. I've got these 2 chips, just 1 gap between them, whereas on here I've had to put 2 gaps between them so that I can add in a little earthing point, a grounding point, which these don't need, of course, because I've got my center grounds here. In fact, you can see here that I've sort of created a ground running between these 3 points by actually soldering bits of wire between the link pins, but it's not a brilliant idea. It's probably easier just to use these green jumpers to distribute the ground. So perhaps it is time now to move on from this project. I mean, I'll probably spend an hour each day, perhaps in the evening, making up all these boards. I've got some more boards there marked up with all the filter numbers ready to go. So yeah, maybe it's time to move on. Mind you, I said that last time, didn't I? Cheerio.